From Earth to Mars in 4 minutes. That's what scientists and new space pioneers like Elon Musk are currently dreaming of. What currently sounds like dreams of the future could soon become reality, as international researchers are very likely on the verge of a breakthrough. In search for faster-than-light travel, the news has been pouring in over the past months and years, and today we'll take a look at what's really going on with warp drive and the like. But before we start, we would like to ask you to support our work. You can do that easily by subscribing to our channel, activating the notification bell, and giving us a like at the end of the video. Let's first take a look at the most important facts about the speed of light. Faster than light. Light spreads out in tiny waves and at breakneck speed. If you switch on a light bulb in your home, the whole room is suddenly lit up. The time from switching it on until it reaches the state of full illumination is something you consciously don't notice. And you can't, because it's less than a fraction of a microsecond. Light has some more interesting properties than just being fast. We know light as emission of the stars in the universe. The light is quasi-created as a byproduct of the stellar fusion processes. Quanta are also tiny particles of light and the building blocks of matter. Quantum physicists suggest that light is one of the main carriers of information in the cosmos. The fact that light is a quantity in the universe was determined by Albert Einstein scarcely 100 years ago. He found out that light, or its speed, is the only constant and not relative force in the universe. The speed of light moving through a vacuum is about 186,282 feet per second. Another cosmic unit of measurement for light is the light year. This indicates the distance that light can travel in the cosmos in 1 year. This value is about 6.2 billion miles. The light year is a unit of measurement used by astronomers and physicists to measure and describe the vast distances in our universe. If humans wanted to travel to Mars, they would need, depending upon the position of Earth and Mars, at the present moment, 5 months to 2 years. If humans wanted to travel under the present circumstances to the end of the solar system, they would be more than 100 years on the way. The comparatively small Voyager probe needs 33 years for this journey to the nearest Alpha Centauri star system, 4.3 light-years away. A large spacecraft would need several thousand years. If we look at these distances realistically, we must admit that we humans still have some work to do if we want to travel through space or even within our own solar system. The dream of manned space travel. Manned spaceflight has been virtually non-existent since the lunar missions. From the 1960s to 80s, NASA sent humans to the moon. At present, humans stay in the cosmos in the space station ISS, close to Earth. But that's it. So far, we have not gone further than the moon, and that was 40 years ago. NASA and the new space pioneers SpaceX and Blue Origin would like to send humans into space again in the foreseeable future. Blue Origin, the spaceflight company of Amazon CEO Jeff Bezos, and Elon Musk's SpaceX are planning manned flights to the moon. SpaceX even wants to send the first scientists to Mars, starting in the 2030s. The big problem with these trips remains the distances, time, and stresses placed on the human body during flights in space. Already, astronauts are only allowed to stay on the ISS for 6 months. Otherwise, they face problems such as muscle atrophy, eye damage, and an increased risk of cancer from high levels of cosmic radiation. Spacecraft traveling at close to the speed of light could reduce the travel time from Earth to Mars to a few minutes. Traveling in a warp bubble would largely spare humans from cosmic rays and other harmful effects of interstellar space flight. Before we get to the point where humans fly with superluminal speeds by manipulations of space-time, we'd need spaceships 2 or 3 times faster than the present ones. An enormous leap in technology. Elon Musk is the first man who wants to send humans to Mars. The announcements of Mars missions and construction plans for a Mars colony have been known for years. Yet recognized physicists and astronomers currently still doubt that projects like these will be realistically feasible unless we have faster spaceships available. In 2019, noted U.S. astrophysicist Neil deGrasse Tyson challenged the SpaceX and Tesla CEO via Twitter. deGrasse Tyson urged the multi-billionaire to stop spending time and money on Cybertrucks, Hyperloops, or Mars rockets. Rather, Musk should look into developing a warp drive. Musk countered at the time that his planned city on Mars will be the powerful driving force to invent warp drive. Exactly what Musk meant by that remains unanswered to this day. No one currently knows whether SpaceX is cooperating with international scientists and working on warp drive or not. How realistic is the warp drive? Up to now, experts have argued whether and how the legendary drive we all know from Star Trek and other science fiction movies will be realizable. As early as the early 1990s, physicists were testing the idea. At first, the prospects were bleak, but as early as 1994, a Mexican researcher presented a calculation according to which the fantastic drive would actually be feasible. As a quick reminder, warp drive sends spaceships through space by compressing space in front of the spaceship and expanding it behind the vehicle. This creates manipulation folds in the space-time fabric over which further distances can be covered in the blink of an eye. In 1994, Miguel Alcubierre became the first person to prove that propulsion did not violate Einstein's laws, as previously believed. The only problem with Alcubierre's solution was the relatively large amount of energy needed to manipulate space-time. Without gigantic reactors on board, his spaceship would not have been able to get off the ground any faster than it did today. But a solution was soon found to this problem as well. In 2010, the U.S. researcher Dr. Harold G. Sonny White found a type of propulsion that requires no fuel or energy at all, and only so-called negative or exotic energy. The new problem that arose was the fact that the existence of negative matter had not been proven in 2010. That changed in 2021. White was able to demonstrate the presence of small amounts of negative matter in the Casimir effect. So far, this is not enough to power a spaceship weighing tons, but the technology could hold promise for the future. This is far from the end of the innovations surrounding warp drive and flying at the speed of light. The EM drive, microwave drive. Before the existence of negative matter could be proven, researchers primarily set out to develop models of super-fast motion that do not require energy. The most promising concept came from a British scientist named Roger Scheuer, a former project manager for the Astrium Space Company. He has developed a hypothetical microwave drive that could rival warp drive. Scheuer's EM drive theoretically works by trapping microwaves in a kind of copper cone and creating thrust by bouncing them off. The EM drive relies primarily on Newton's second law, which defines force as the rate of change of momentum. The electromagnetic wave propagating at the speed of light has a certain momentum which, when transferred to a reflector, results in a tiny force. Accumulated accordingly, the tiny amount could become such a large force that the EM drive, without any propellant at all, might not be able to reach the speed of light, but it would be a significant improvement. NASA announced that tests with an engine based on EM technology had been successful several times. Shortly afterwards, a scientific group from China announced that it had also successfully tested this engine. Tested in Dresden and found to be unsuitable. Critical scientists did not readily believe the results of NASA and the Chinese. Ideas about microwaves generating thrusts sounded too unreal, and some German physicists raised questions such as how these waves should be initiated, how they should move, and where they should get their momentum. Consequently, they were put to the test. The test took place at the Technical University of Dresden. In Dresden, they came to quite different results, and the researchers told NASA and their Chinese colleagues that something could not have been quite right with their test series, because in Dresden, the EM drive failed despite several attempts. Since NASA did not comment further on these criticisms and no statement could be heard from China either, all hopes have turned back to the warp drive. After all, once implemented, it could solve almost all the problems of manned spaceflight in one fell swoop. In an artificially generated warp bubble, it's not the spaceship that moves, but the universe. so to speak. In the best case, the occupants of a warp spacecraft would not notice much of their interstellar journey. Will Dr. Eric Lentz bring us warp drive? When Captain Picard was jetting through space and time on the Enterprise, physicist Eric Lentz, now 34, was still a young boy. Even then, Lentz couldn't stop wondering whether warp drive was realistically possible. During the pandemic, Lentz, who had almost lost his job, took another look at the Alcubierre drive and Dr. White's improvement out of boredom, looking for a solution to the energy problem. Due to a special circumstance in the geometry of space-time, Lentz found solutions for the drive that did not require the use of exotic or negative energy at all. He discovered the solution in Einstein's field equations. Thanks to these, one can calculate how certain matter and energy distributions distort space-time. Like Alcubierre, Lentz decomposed space-time into stacked layers for this purpose. Only the practical astrophysicist Lentz searched for much more complex units than the theoretical physicist Alcubierre and found them. Lentz's draft provides for the use of a large quantity of energy, for it consistently uses positive forces whose existence is already known, confirmed, and available. Positive energy is a concept that goes back to the Swiss research group Applied Physics, another group that presented the concept of a superfast propulsion without fuel. Although the model does not go beyond the speed of light, it could realistically advance space travel enormously in just a few years. We remain curious about the innovations we may soon be able to announce here, and hope, of course, that you'll be there for it. Tell us what you think about the future of manned spaceflight and the development of a faster-than-light drive. Do you think warp drive will be possible soon? Write your ideas and suggestions in the comments. We'll see you next time at Simply Space.